All right, guys. So in this video, we're going to take a look at graphing piecewise functions. Now, this isn't something that I'm going to test you on, but you might have some homework assignments on it. So I want to at least go through a couple examples so that you've seen it before. Okay. All right. So we have a piecewise function here. F of x is equal to negative 2x plus 4 when x is less than 0, and x squared minus 1 when x is greater than or equal to 0. So just like most functions that we're going to graph in this class, if you want to graph a function, typically you're going to want to start by making a table of values. So that's where we're going to begin, okay? Now here's kind of the trick to graphing piecewise functions. Wherever you have the switch between one equation and the next, in this case, our function switches between the top equation and the bottom equation at x equals 0. I want to put that x value in the middle of my table, okay? And I want to make sure to choose a few values on either side of it because I need to have at least a few points with either equation to get a good idea of what this function looks like. So I'm going to go ahead and pick 3x values on either side of that transition point at x equals 0. So I'll go -3, -2, -1 on the left-hand side of it, and 1, 2, 3 on the right-hand side of it. Okay, now we just need to start plugging these into our functions. So for x equals -2, or -3, -2, and -1, these values are all less than 0, so they're going to go into that top equation. Okay. Where on the other hand, x equals 0, 1, 2, and 3 are greater than or equal to 0, so they're going to go into the bottom equation. All right, so let's go ahead and just start plugging these in. All right, so let's begin with x equals -3. So plugging that into the top equation, -2 times -3 is 6, plus 4 would give us 10. All right. Plug in a -2. So -2 times -2 is 4, plus 4 would give us 8. And then plug in a -1. -2 times -1 is 2, plus 4 would give us 6. Okay, now here's something that you just have to remember to do with these piecewise functions. So although this top equation is not defined for x equals 0, we use this top equation all the way up to 0. So if you were to look at -0.5 or -0.25 or -0.0001, all of those x values would be less than 0 and they'd have to go into this top equation. So we sort of want to see where is this function leading right up until that x equals 0 point when it switches over to the other equation. So we still want to plug in x equals 0, our transition point, into that top equation, even though our top equation isn't defined there. The main difference is going to be when we plot this on our graph, we're going to have an open circle for this point instead of a closed circle. So if we plug 0 in right here, -2 times 0 is 0, 0 plus 4 is 4. So I'm going to put this in parentheses just to remind myself that this isn't an actual point on the graph, but instead it's going to be an open circle instead of a closed circle, okay? All right, then from here on out, everything is greater than or equal to 0, and we're going to plug it into that second equation. So starting at 0, 0 squared is 0, minus 1 is -1. 1 squared is 1, minus 1 is 0. 2 squared is 4, minus 1 is 3. And 3 squared is 9, minus 1 is 8. Okay, so all of those we plugged into the second equation because they were greater than or equal to 0. All right, so now we just need to plot our points. So our first point, we have -3, 10, then -2, 8, -1, 6. And then remember this point right here, the 0, 4, because the top equation doesn't include x equals 0, we're going to plot this point 0, 4 as an open circle on our graph. Okay. All right, then at 0, we actually use the second equation, so 0, -1 is the actual point. That's our closed circle. Then we have 1, 0, 2, 3, and 3, 8. All right, and then just connect your points. So all of our blue points are going to connect. Those came from the top equation. And then we jump and connect all of our purple points that came from the bottom equation. So these two pieces are not connected to each other. There's a jump in our graph right here because the top equation was leading us to 0, 4. The bottom equation picked up at 0, -1. Okay, so when you're graphing these piecewise functions, they may not connect. You might have a gap in them, you might have a break in them, and that's perfectly okay. So you just want to think about where's the first equation leading, plot that open circle at wherever your transition point is, and then keep going with your second equation. All right, guys, let's go ahead and look at one more example just to get a little bit more practice with this. So this next one, our function is f of x is equal to x plus 3 when x is less than -2, and -2x minus 3 when x is greater than or equal to -2. So again, this point where our graph switches, or where our function switches from one equation to the next at -2, I'm going to go ahead and place that in the middle of my table of values that I'm going to make. And I want to pick a few x values to the left of -2, and I want to pick a few x values to the right of -2. So I'm going to go -5, -4, -3 on the left, and -1, 0, 1 on the right. Okay, so in this case, -5, -4, and -3, those are all less than -2 and go into the top equation. -2, -1, 0, and 1, those are all greater than or equal to -2 and go into the bottom equation. So now we just start plugging them in. All right, so starting with our -5, plugging that into the top equation. -5 plus 3 is a -2. Plug in a -4. -4 plus 3 is a -1. And then -3 plus 3 gives us 0. Okay. Now, just like on the previous example, although the top equation is not defined at -2, it's defined everywhere leading up to -2. So we're still going to plug -2 into that top equation. It's just that this is going to appear as an open circle on our graph. So if we plug a -2 into our top equation, -2 plus 3 gives us a +1. And I'm going to put that in parentheses, reminding myself that this is an open circle on our graph. Okay. All right, then we switch to the bottom equation. So plugging in a -2 here, you get 4 minus 3, which is a +1. Plugging in a -1, 2 minus 3 is a -1. Plugging in a 0, 0 minus 3 is -3. And then plugging in a 1, -2 minus 3 is a -5. Okay. All right, so then now we just go ahead and plot all these points. Okay. All right, so we have -5, -2, -4, -1, -3, 0, and then we have this point right here, -2, +1 that came from the top equation, and we're going to plot that as an open circle. So -2, 1 from the top equation is an open circle. All right, well, this time, interestingly enough, we also got -2, 1 from the bottom equation. So we plot that same point right here, and this time it just fills in that circle. So this time our two equations happen to coincide at that transition point of -2, but as we saw in the previous example, that's not always going to happen, but it can. Okay. All right, and then just keep plotting these points. So -1, -1, 0, -3, and 1, -5. Okay. All right, and then just connect our points. So connect all your blue points together, connect all your purple points together, and we're good to go. All right, guys, so I hope that helped you a little bit with graphing these piecewise functions. As I said at the beginning, this isn't something that I'm going to be testing you on. All right, you do need to know how to evaluate piecewise functions for the test, but the graphing part of it specifically, you may see in homework problems, but you won't be seeing it on the test itself.